Hi everyone. Today we want to provide you with a gentle introduction to Git. Git is a source code management system that was developed by Linus Torvalds for Linux. It's gained wide popularity. It runs on not just Linux these days, but on Mac and Windows and other platforms as well. It is very pervasive within the developer community, regardless of what language or technologies that you're using. It's just a really valuable tool. And we'll go into what makes it a valuable tool. This video is for the absolute beginner. If you're not uh, if you're not familiar with Git, you're just trying to find out the basics, then this is the place to start out. If you're a more experienced developer and you're looking for some more added polish to your Git skills, then there are other resources that would be better than this one. So with that, let's get started. Let's dive right in and talk about what are Git and GitHub. So Git is a tool that you use. It's a piece of software that helps you manage your source code, your project, locally on your computer. GitHub, on the other hand, is a hosting service, if you will, that uses Git, but it's the place where you put your project so that it can be shared by other people. If your project is an open source project, you're making it available. You can make it available on GitHub just for other people to see and to use. If you're working in a team environment, you're developing or co-developing a project with other folks. It's a place for you to share your changes and to merge your changes with your teammates. So again, what Git does and what Git and GitHub help you do is they help you manage your source code as an asset. You know, uh, uh, arguably, the most important thing in the project is your source code. If you lose your source code or if it becomes damaged, you are in a world of hurt because it's really tough to rebuild. And that's one of the advantages of Git. It helps you manage your code in such a way that you maintain the integrity of your project. Uh, Git is distributed, and that's its real uh, advantage over older source code control systems. In the old days, if you go back to the mainframe days, source code control systems were like a library. Files were like books. You could check a book out to do your updates or to reference it, but nobody else could reference that book while you had it checked out for update. So, you can imagine the kinds of issues that would arise from that. I could check out a file, a program to modify it, go on vacation without checking it back in, and nobody else could easily get to my changes. Uh, anyway, that was a big problem. Well, with Git, what it does is members of your team can simultaneously or concurrently update the same files in a project. And when you check in your changes back into GitHub, uh, your changes are merged with other team members' changes. Um, so that's a real advantage of Git over older systems. Um, so for example, if you have a particular project file as shown here, um, your three teammates that you're working with can all be updating or referencing that same file at the same time from their local Git repository. And that's a bit of terminology. Your repository on your computer is the local repository. The GitHub repository is a shared repository. So let's move on. So again, GitHub is the place where your repository sits so that it can be shared across all your team members. Whereas Git itself is software that manages the project on your local computer. So another concept which we'll just touch on briefly, because it's something you've probably heard of, but we're not going to go into any depth, is the Git workflow. Basically, the workflow is something that you and your team create. That's the pattern, if you will, of Git operations that you use to manage your project. So it's the conventions your team follows as you're working on your source code. And every member of your team will want to follow this same workflow. And what the workflow does, its purpose is it promotes efficient development, and it also protects the integrity of the files in your project because you're all managing your project the same way. So that's a brief overview of uh, Git and GitHub. Why don't we take a look at what three of the most common tasks are when you're managing a personal project, a project that you're not sharing with any other teammate. Let's go through what those three tasks are. So the first task is you'll need to create a Git repository on GitHub. And the way you do that is if you go to your GitHub page, you'll see a list of your repositories on the left, and you'll also see a new button on the top that's in green. Click on New, and we're going to create a new project, and we're going to call it Hello Git. And we'll give it a description. Now in Git, you can define your projects as public or private. In many cases, they will be public, especially as you're starting out and you're creating projects for your portfolio to show to prospective employers, for example. Anyone can view and can clone and can fork a public repo. If you mark your repo as private, you are the only one that can see that particular repo. So we'll initialize it with a README, and we can add a license. We'll do an MIT license in this case. We'll skip the git ignore for now, and we'll click on the create repository to create it. So now GitHub is creating our new project. It's populated it with a default README file. It's also populated it with a license. In this case, the MIT license, and it lays out very nicely an overview of what's entailed in that license. The other thing to point out is that, just briefly, is that you could have multiple branches in a repo. So by default, we're in the master branch. As you're making changes to your projects, you could create new branches that's just for your changes. And then at a later point in time, you'll integrate those changes into the master branch or whatever the production branch is for your project. So this completes task one. We've created a brand new repo on GitHub. So our second task that we'll do is we're going to want to bring that repo down onto our local machine. So to do that, what we'll do is you'll notice this clone or download button in GitHub. We'll click that, and then we'll hit this clipboard icon to copy that to the copy paste buffer. And then we'll flip over to or switch over to our terminal session. Now, in my case, I use iTerm on the Macintosh. Some people use other terminal window software. Some people prefer to use their integrated development environment like Atom or Visual Studio Code to do their Git operations in. I prefer to use a terminal window. It's just my preference. You can choose whatever method suits your needs. So our second task is we want to bring that GitHub repository we just created down to our local machine. So what we'll do is we'll do that through a command called git clone. And we'll paste in the URL of the GitHub repo we created. In this case, it's hello Git. Hit enter. And what's happening right now is our local Git software on our machine has used that URL to access GitHub. It's created a local directory called Hello Git, and it's populated it with the contents of our repo that as it was defined on GitHub. So we can display the directory, or actually we can change directory to Hello Git, and then list the directory, and we can see it has our license file and our README file. So we've accomplished task number 2. We've brought that repo we created on GitHub down to our local machine. So now we're just going to make a change. I'm going to go into the README, and I'm just going to add a line, or modify it. So I use the Vi editor. I changed the README just to add some text to it, and I saved it back. So now we're ready to head to our third and final task. We want to push our changes back up to GitHub. But as a developer, one of the questions you may have from time to time, especially if a particular change takes, not a minute, but takes hours or potentially days, you want to know what you've changed. So a git command we can use is git status. And in this case, it tells us that we've modified the readme.md file. So now what I'm going to do is I'm going to commit this file. I'm going to add my changed file to Git. Basically, this is saying I'm no longer operating on a working copy of the modified README file. I want to make that change permanent. That's what the git add does. And then now I want to commit that change. So I'll do git commit. And what git commit does is it allows me to describe what was the change that I made, and more importantly, why did I make that change? So in this case, I'm going to add a description. This is a feature. And I'm just going to say add an additional explanation. And that's it. This can be quite lengthy, especially as your changes get more complicated. Again, there are ways in Git to display what are the changes from commit to commit. We're not going to go into those today, but just be aware that type of functionality is available. It's more important to describe in your commit, why are you making the change? What's the purpose of the change? Why are you making it? What drove you to this point? In many cases, you'll find that commit messages include the issue numbers of bugs that you may be fixing in this commit. So we wrote that back out. So now our change is committed in our local Git repository. So we're going to push it back up to GitHub. And to do that, we'll do git push origin master. So what this says is we want to push our committed changes up to our origin. Origin is GitHub in this case. And then our branch that contains the changes is the master branch. So you can see from this, we get a summary of what was the extent of the changes. There were 3 objects for 350 bytes. And they were successfully pushed back up to the Hello Git repo in GitHub. So now, let's change or go back to GitHub. and we'll refresh our screen, and we'll see if our changes made it up. So again, GitHub is really nice. It's given us this line of informational text that says, this is our commit message. We added an additional explanation to the README documentation, gives us a unique number for that commit, and tells us when the change was made, how long ago, in this case, 2 minutes. And then we can scroll down and we can see this was the text that we added to our README. If we want to see more, we can click on the commit message, and you can see it shows us the before and after versions of the line that was changed, which is really, really nice. So those are the three main commands you will use when you're managing a personal project. In other words, not a team project, but a project that you and only you are working with in Git. So I hope this has been helpful. Again, this has been a very gentle introduction to Git and GitHub. And what I would encourage you to do is, if you don't have a GitHub account, create one and create a sample repo that you can play with, one that you can afford to make a mistake and to learn from those mistakes. It's better to do that now than it is when you get in an actual team setting. So again, I hope this has been helpful and useful, and we will see you later. Bye-bye.